Hey guys, this question asks, what is the relationship between the compounds shown? Okay, so I can tell these are not constitutional isomers. That's relatively easy to see. It's 2 cyclohexane rings for both of those, and you have an OH group that is 2 carbons away from the carbon that it connects the 2 rings from each other. So 1 2 1 2, but it's a little difficult to compare the 2 compounds when they're so obviously drawn differently. So let's take one of these guys and just flip it over. So imagine if I were to grab this compound and just kind of drag it down. So if I were to rotate it about this axis, if there's an axis that goes through the compound like that, and I rotate it 180 degrees like that, that way, what will I get? I would get, again, the 2 6-membered rings, but now this hydrogen would be to the back, and this one here would be to the front, and this guy here would be at the bottom, but instead of pointing to the back, it would point to the front. This one's kind of a tricky one. If you want, you can build the model kit and kind of see it for yourself. Use a model kit and build the structures and see it. Now we have something interesting. We see that the OH is in the right place and everything else looks exactly the same, but here we have different stereochemistry. So this is a stereocarbon. That's a chiral carbon right there, or an asymmetric carbon. And so are these two. Both those carbon atoms are chiral or asymmetric, and because of that, these 2 chiral carbons have the same stereochemistry, but those 2 differ, and so do those 2, and therefore these compounds are therefore diastereomers, because some chiral carbons have the same stereochemistry, the same absolute stereochemistry. In other words, both are R or both are S, and some of them differ. So this one might be R and this one might be S, or vice versa. And when you see that, those are diastereomers. For them to be enantiomers, they would have to have the exact opposite stereochemistry at all 3 chiral centers. So this would have to be RRR, and then this will be SSS, or RSS and SRR. And for them to be identical, they would have to have the exact same stereochemistry at all 3 positions. So these are diastereomers. Thank you for watching.